Today, we're diving into some ACT math geometry, specifically angles in triangles. Alright, let's warm up with the basics first. We all know that the sum of the three interior angles in any triangle is 180 degrees. Now here's the fun part. How do those angles change when the sides change? If two sides are the same, that's an isosceles triangle. If all sides are equal, it's an equilateral triangle. In an equilateral triangle, every angle is 60 degrees, since 180 divided by 3 equals 60. In an isosceles triangle, the angles opposite the equal sides are also equal. Now, what about exterior angles? Let's clear that up real quick. Whenever you extend one side of a triangle, that exterior angle equals the sum of the two opposite interior angles. Okay, let's jump into problem 1. We've got an isosceles triangle, so the two angles opposite the equal sides are the same. We already know the third angle, so finding the other two is just a quick subtraction away. Now let's take triangle BCE. Angle ABE is the exterior angle so that it is 80 degrees. When triangle ABF is concerned, the exterior angle BFD can be calculated. Let's move on to the next problem. So first, triangle ABD is equilateral. All sides are equal, and every angle is 60 degrees. Now slide over to triangle BCD. It's isosceles, and we're told DB equals DC. Then triangle DEC is also isosceles with ED equals EC. All right, let's zoom in on triangle DEC. Since the sides ED and EC match, the opposite angles match too. Let's call each of those angles X. Here's where it gets interesting, because DB equals DC, and DB is one of the sides of our equilateral triangle. ABD. That means AB, AD, DB, and DC are all the same length. Now look at triangle ADC. AD equals DC, so the angle CAD must also be X. Add up the interior angles of triangle ADC. We get 180 degrees, which gives us X equals 40 degrees. Since angle DAB is 60 degrees, we can easily find angle BAC from there. And yep, the correct answer is choice B. Now, we'll move on to the last problem for today. If the diagram is symmetrical, that means our pentagon MNOPQ has 5 equal interior angles. But how do we actually find them? All right, let's break it down. First, we'll grab the sum of the interior angles of a pentagon. Easiest way, split it into 3 triangles. 3 triangles is 540 degrees total. South. If all 5 angles are equal, we just divide. 540 divided by 5 equals 108 degrees for each interior angle. Now we can get angle AQM, because the angles on a straight line always add up to 180 degrees. And once we have that, we use the exterior angle idea to find QAM. And yep, the correct answer is option C. That's how you break down triangle angle problems step by step for the ACT math test. If you found this helpful, give it a thumbs up.